So in this tutorial, I want to go over something called the common ion effect, where it's just basically, let's say you have an acid ionization or a base ionization already taken place. Now you're adding some other substance to it, but that substance already has, or it has, one of the ions that is already in the system itself. So you want to see what's going to happen to that equilibrium if you do something like that. So basically the question to ask is, what effect will adding another solute to a system have on an acid or a base? Again, especially if that other solute has an ion that's already in the system itself. How will the degree of ionization be affected? Will it increase or will it decrease? Will you have that particular acid breaking down completely, or will it will it hold it back a little bit? And you will have a shift in equilibrium that occurs, when that solute is added, and this is what's known as the common ion effect. So let's say we take the following example. You have acetic acid being ionized in water, to form an acetate ion and the hydronium ion. What's going to happen if you actually add HCl to this? So let's actually go and do it. So if you add HCl, HCl breaks down basically, and when it breaks down, you form H3O plus and Cl minus. Cl minus doesn't really have any effect on this because you don't have any other Cls within this ionization, but you do have the H3O plus, and that H3O plus is going to be added to the H3O plus that's already there. So if you're adding more and more H3O plus to this particular substance, or this particular ionization taking place, going back to Le Chatelier's principle, where it's just basically saying, if you add a substance to something that's already at equilibrium, it's going to shift to use it up. In this case, this is going to shift to use up that excess H3O plus, so it's going to shift to the left to do that. Because it's shifting to the left, that means the degree of ionization of Hc2H3O2 should decrease, because of the fact that it's no longer breaking down in water, because that H3O plus is keeping it from breaking down in water. So it will decrease. So let's just take this following example, where basically you have a degree of ionization of acetic acid at 0.013, and the concentration of this particular solution is 0.1 molar. It gives you a Ka, so 1.7 times 10 to the negative 5. Now you need to go and calculate the degree of ionization that's going to occur if that same exact solution is now going to have HCl added to it. And the HCl that's added to it is 0.010 molar HCl. So how is that degree of ionization going to be affected? So because we're dealing with ionization, you have your Hc2H3O2 being ionized in water, so plus H2O, and it's going to yield C2H3O2 minus plus H3O plus. So that'll be the ionization equation for this particular reaction. So knowing that, let's set up our ice table. So you have the C2H3O2. Water doesn't go into the ice table because it's a liquid. So then you have C2H3O2 minus, and then you have the H3O plus. So that's how you set up the ice table. Now, initially, going back to the problem, you notice that we had 0.10 molar, so for the acetic acid. We didn't have any of the acetate ion, but we did have HCl being added to the solution, and so this will go here, as the 0.010, because of the fact, again, that if you were to go and put HCl in water, it would form H3O plus and Cl minus, so it is going to add to here. Change in this case, negative X, because that's your reactant, and then a positive X for the other two, because those are your products. So then the equilibrium in this case would be 0.1 minus X, X, and then 0.010 plus X, because again, you're on the positive side of this. So then if you were to set up your equilibrium expression, or your ionization expression, you'd have your H3O plus, and then your C2H3O2 minus, all over your HC2H3O2 at a particular Ka, which that was given to you in the problem, which it happened to be 1.7 times 10 to the negative 5. So then if you were to go and plug in your numbers as you did before, or as you've learned how to do before, for H3O plus you have 0.01 plus X, and then for the C2H3O2 it would just be plain X, and that's all over 0.10 minus X. Now, as we've dealt with this previously with other acid-base equilibrium, the plus X and the minus X, the change is, we're assuming that the change is so small that's not really going to have an effect with anything, so we can get rid of that. So instead, you'd end up with 0.01 on top and then 0.1 on the bottom, just to make things a little bit easier. So then actually if we were to rewrite this, you would have 0.01x over 0.10 equals 1.7 times 10 to the negative 5. Now it's just simply going and solving for x. So you would cross multiply with the 0.1 times 1.7 times 10 to the negative 5, and then divide it by the 0.01. And so if you were to do out this math, you'd end up with an x of 1.7 times 10 to the negative 4. Now we need to figure out the degree of ionization that's taken place. So to do that, we take what our equilibrium value was, which is 1.7 times 10 to the negative 4, and that's going to be over what it was originally, which was 0.1. So if you do that out, we end up with a degree of ionization of 0.0017, and if we were to compare that with what we were originally given, which was 0.013, you notice that it's considerably smaller. So as I was saying before, with whenever you add another ion to your ionization equilibrium, what's going to happen is that the degree of ionization is going to go down, and as you can see here, it did. So let's move on to the next type of problem, which in this case, you're looking for the concentration of formate ion, which is CHO2 negative, and you start off with 0.1 molar of the acid, of HCHO2, and what you're going to do is start adding H3O plus to it, which is 0.20. And the other part that you need to do is figure out the degree of ionization of this, which we will do after that. So first thing you always want to do when you're dealing with ionization is just do out the equation for it. So you have HCHO2 plus water yields CHO2 plus H3O plus. Now let's plug everything into our ice table. So you have HCHO2 and then CHO2 minus and H3O plus, like that. Now in this case we did end up with again having H3O plus already put into place in this, so that originally we start off with 0.1 formic acid, so 0.1 goes there. We also start off with 0.2 HCl, so we do need to make sure we take that into account. And then for the formate ion, we didn't end up with anything. So now just put in your change, so negative x, x, and x. So you have 0.1 minus x, regular x, and then 0.2 plus x, because again, it's your product, so you do need to make it positive. So now if we were to set this up, we had a Ka of 1.8 times 10 to the negative 4 equal to the H3O plus, which we had as 0.2 plus x, but again, because of the fact that the change is going to be so small, we don't need to put that in, so you just have 0.2 and then x, and that's all going to be over Originally it would have been 0.1 minus x, but again the change is so small, so you just have 0.1. So now if you were to do that math out, you end up with an x of 9 times 10 to the negative 5 for a concentration. So that's your concentration of the H3O plus. If we were to go and do the degree of ionization, what we got at equilibrium goes up top, and then on the bottom goes what we originally started off with, so 0.1. So you end up with a degree of ionization of 0.0009. Alright, so the next example, in this case, we're going to mix things up a little bit, where you start off with 0.1 acetic acid, and instead of starting off with, instead of adding to this HCl, let's say, you're now adding the salt to it, or in this case the sodium acetate, which will be done similarly, similar to what it was before, but now instead of dealing with the H3O plus, you'll be dealing with the salt ion instead. So first thing you want to do is just again do out your ionization equation. So you'd have HC2H3O2 plus H2O yields sodium acetate, or the sodium part you don't need to take into account, so just add the C2H3O2 minus plus H3O plus. So now let's set up our ice table. So you have HC2H3O2, you have your acetate ion, and then you have the H3O plus. Now we put in our initial values, which for the acid it was 0.1. In this case we had sodium acetate, so for the acetate ion we have 0.2, because that's what we initially started off with. And then for the H3O plus, just put 0 because we didn't have any of that yet. For the change you have negative x, positive x, positive x. And then if you do this out, you have minus 1 plus minus x, 0.2 plus x because it was a product, and then just x. Now if we set up our equilibrium expression, we have 1.7 times 10 to the negative 5 as our Ka, equal to what we had for the acetate ion, which was 0.2 plus x, but the change is so small we don't need to put it, so we're just going to be 0.2, and then for the H3O plus it was just x, and that's all over the HC2H3O2, which is just going to end up being 0.1. So if you do out this math, you end up with an x of 8.5 times 10 to the negative 6, which happens to be what the H3O plus is going to be equal to. Because of that, we can easily take the pH by just taking the negative log of H3O plus, and so you end up with 5.07. Alright, now for this last example, in this case this is going to be similar to the one we just did, where we have 0.25 moles in this case of formic acid, and you have 0.018 moles of sodium formate. This is all in 1 liter though, so we don't have to deal with dividing by the volume, because it's just going to end up being the same thing. And basically what we're looking for is the pH of the solution. So as always, do out your acid ionization equation. So HCHO2 plus H2O yields CHO2 minus plus H3O plus. Set up your ice table, so you have HCHO2, you have the CHO2 minus, and then you have the H3O plus. Initially for the acid we had 0.025, because again it was in 1 liter, so we don't have to go and divide by anything. CHO2, we had sodium formate at the beginning, and the amount we had was 0.018, so that's where that would go. H3O plus we didn't have any, so that would be 0. So then you have a minus x, positive x, positive x, and then you just do out your equilibrium. So 0.025 minus x, 0.018 plus x, and then x. Now do out your equilibrium expression. So you have 1.7 times 10 to the negative 4 equals